Hi, my name is Kwan Long, and the subjects that I specialize in teaching are AP Psychology, AP Statistics, and AP Physics. Hi, so today we'll be attempting to derive the electric field at the center of a semicircular arc of charge. This is one of the derivations that you need to know how to do in order to succeed in AP Physics C. So to begin, let's start off with a standard coordinate plane, and let's have a semicircle of charge here. And then this semicircle will have charge negative Q. All right, so our goal right now is to find out what the electric field is at the origin. So right there. So before we do anything, let's label some things. Let's say that this distance from the origin to one end of the arc is distance r. And like every other electric field derivation, we're going to take a very, very small segment of the arc and call it dq. So we'll take this segment and call that dq. And since it'll be much easier for us if we work with symmetry, we'll also take another segment here and call that dq. All right, so if we look at the electric field caused by just two of these dqs, the field lines will point as such. And we can call these two dE there and dE there. And for our example, we'll be using the x-axis as our reference axis. So let's just label that. Oops. Label this our reference axis. And we will say that the angle between our DE and our reference axis is angle theta. Okay, so we'll notice that in our diagram, the two DEs, their x components will cancel, as we see here. So we can split this into DEX here and DEY here, right? So this would be DEX, and that would be DEX, and you'll see that these two will cancel. So in the end, it'll just end up with a electric field like that, and we'll just call that the E net. And all of this is gone. Okay, so now let's take a look at a more magnified view as to what we are looking at. And so it would be like a small piece of pizza, and what's in here is d theta. This is r, and this chunk right here is dq. And the whole thing is ds. So before we actually begin our derivation, we need to find out what we know first, and we'll work from those equations. So we know that s equals r theta, which means that ds will also equal to r d theta. And we also know that lambda, or the linear charge density, is equal to q over L. And in our case, our charge is q, and our length is pi r, because it is half of a circle, which will equal to dq over ds. And from there, we can find out that dq is equal to lambda times ds. All right, so now that we have all of this, we can begin our actual derivation. So as like every other one, we have E equals kq over r squared. And then from there, we can see that dE will equal k dq over r squared. And right here, as we said so before, since the x components cancel, we will multiply this thing by sine theta. Why? Because the x, oops, let's use a different color for that. Because the x components cancel. Components cancel. All right, now let's zoom back in here. So to continue our derivation, we can substitute what we found before into what we have now. So we'll see from the stuff at the top, we can substitute in and find that dE equals k lambda ds over r squared times sine theta. And then from there, we'll continue to simplify and find that dE equals k lambda d theta times r over r squared sine theta. And then we'll realize that the r's cancel, leaving only one r at the bottom. And right now, we're going to integrate. So dE will equal to, let's take out our constants first before we integrate. What are our constants? K, lambda, and r. They're all our constants. So, and then we'll multiply by sine d theta. And then right here, we'll integrate from here to here. And our limits will be from 0 to pi, since it's a semicircle. And then what we'll do next is we'll find out that E will equal to K lambda over R. Since these are constants, they're always conserved. And then we'll also have cosine pi minus cosine 0. Right? Oh, and there is a negative sign here because we're taking the integral of sine. And then this can be further simplified into negative k lambda over r times -1 minus 1. So ultimately, you'll realize that the electric field will equal to 2k lambda over r. And this is the electric field for a semicircular arc of charge. And in AP Physics C, you will need to know how to do all of this. So I hope this helped, and thank you for watching.